A very good morning. I, Dr. Gauri, Assistant Professor, Department of Zoology, on behalf of organizing team, Department of Zoology, Deshbandhu College, University of Delhi, welcome you all to the webinar on paleontology. I express deep gratitude to our principal sir, Dr. Rajiv Agarwal, who could not attend this meeting but allowed us to conduct this program. I extend warm welcome to our much esteemed speaker, Dr. Pramod Kumar, Assistant Professor, Department of Geology, Center of Advanced Studies, University of Delhi. Dr. Varsha Babeja, our teacher in charge, the senior most faculty members, Dr. Ranjana Seth, Dr. Kamal Kumar Gupta, Life Science Coordinator, Dr. Manisha Sanger, DBT Star College Coordinator, Dr. Indrakant Kumar Singh, all the esteemed faculty members and dear students for gracing the occasion with your benign presence. I request Dr. Kamal sir, please address the August gathering and give us some insight into the conceptualization of this webinar. Over to
धन्यवाद
you, sir.
धन्यवाद डॉक्टर गौरी. Am I audible?
Yes.
मेरी आवाज आ रही है? ओके. धन्यवाद डॉक्टर गौरी नंदी. संगोष्ठी में उपस्थित सभी सदस्यों का स्वागत. मैं कमल कुमार गुप्ता और हमारे मुख्य अतिथि डॉक्टर प्रमोद कुमार, वरिष्ठतम अध्यापिका डॉक्टर रंजना सेठ, शिक्षक प्रभारी डॉक्टर वर्षा बबेजा, लाइफ साइंस सोसाइटी की समन्वयक डॉक्टर मनीषा सेंगर, डीबीटी स्टार कॉलेज के संयोजक डॉक्टर इंद्रकांत, आईक्यूएसी के संयोजक डॉक्टर आदित्य सक्सेना, हमारे प्रधानाचार्य डॉक्टर राजीव अग्रवाल का अपनी तरफ से और विभाग की तरफ से स्वागत करता हूं. आज की संगोष्ठी का आयोजन के लिए मैं डॉक्टर प्रमोद कुमार, डिपार्टमेंट ऑफ जियोलॉजी, एवं डॉक्टर प्रसाद का तहे दिल से धन्यवाद देता हूं. इस संगोष्ठी के पीछे उनका मुख्य भूमिका है. पाठ्यक्रम के अनुसार विद्यार्थियों को एक प्राकृतिक संग्रहालय की विजिट करनी होती है, लेकिन कोविड-19 आपदा के तहत यह विजिट नहीं हो पाई और इसके विकल्प में हम यह संगोष्ठी आयोजित कर रहे हैं. अगर मैं इस संगोष्ठी के विषय में बताऊं तो यह प्रकृति का नियम है, सृष्टि का सृजन और संहार. सभी धर्म के अनुसार से सृष्टि बार बार उत्पन्न होती है और उसका संहार होता है. सृष्टि ही क्यों, जीव की उत्पत्ति का बाद उसकी मृत्यु निहित है. और ये जीव ही नहीं, इवन छोटे छोटे अणु, उनका भी सृजन और संहार होता ही रहता है. तो यह प्रकृति का नियम है कि जिसकी उत्पत्ति हुई है उसका विनाश भी होगा. यही शायद विकास का नियम है, यही विकास की विकल्प है. अगर आज डायनासोर्स होते तो क्या मनुष्य का विकास हो पाया होता? शायद नहीं. नई चीज के लिए पुरानी चीज को जाना ही पड़ता है. यह सृष्टि में अनेकों बार हुआ है. इसके लिए डॉक्टर प्रमोद हमें अपने ज्ञान से बताएंगे कि बार बार पृथ्वी पर मास डिस्ट्रक्शन हुआ, मास एक्सटिंक्शन हुआ, कारण शायद कुछ भी रहा हो. तो अब बिना विलंब के मैं डॉक्टर प्रमोद को मंच पर बुलाने के लिए डॉक्टर गौरी को आग्रह करूंगा और अपनी वाणी को विश्राम दूंगा. धन्यवाद. धन्यवाद डॉक्टर गौरी, ओवर टू यू।
धन्यवाद सर, हिंदी में अपने विचारों का प्रदान करने के लिए। सर, हम आपके बहुत बहुत आभारी हैं सर। Thank you, sir, for enlightening us with your thoughts, sir. Thank you, sir. Sir, I now invite, ma'am, I now invite Dr. Manisha Sanger, ma'am, Coordinator Life Science, to please introduce our speaker. Formally welcome and please introduce our esteemed speaker.
धन्यवाद गौरी, धन्यवाद गौरी। मैं सर को इंट्रोड्यूस इंग्लिश में करने की अनुमति चाहूंगी। गुड मॉर्निंग, आप सबको सुप्रभात। I feel very proud to share the CV of Dr. Pramod Kumar. Dr. Pramod Kumar is presently teaching in Department of Geology, Center for Advanced Studies, University of Delhi. Since 2009, he is also a postdoctoral fellow under UGC Dr. D.S. Kothari Fellowship Scheme. Dr. Pramod Kumar completed his graduation and post-graduation from the famous Banaras Hindu University. Sir did his PhD from Indian Institute of Technology, Bombay, in shell bed taphonomy, paleoenvironment, and sequence stratigraphy. His areas for interest include sequence stratigraphic interpretation in mixed carbonate silicilastic systems, shell concentration, micropaleontology, ichnology, and coal and petroleum geology. Dr. Pramod has over 10 research publications to his credit and has presented many papers in many national and international conferences. Sir has undertaken many projects as a principal investigator, the projects being funded by Department of Science and Technology and University of Delhi. He has many undergoing projects that are funded by the biggest agencies in India. Dr. Pramod Kumar is also a recipient of many prestigious scholarships as CSIR NET and ONGC Merit Scholarship. Sir also cleared his GATE scholarship and in geology and geophysics. Dr. Kumar is member of various professional bodies like Journal of Geological Society of India, Arabian Journal of Geoscience, International Journal of Advancement in Earth and Environmental Science. Sir is also a member of American Association of Petroleum Geologists, Society of Sedimentary Geology, SEPM, Geological Society of America, GSA, Association of Petroleum Geologists, APG, India and Society of Geophysicists, SEG. Sir has also organized Mars Rover exhibition and the Tech Fest. There are innumerable other projects to Sir's credit. Sir, I welcome you and invite you for the much awaited talk. Thank you.
Thank you, Doctor. So should I go for presentation now?
Yes, sir.
Okay. So let me share my slides. Is the slide is visible to you?
Yes, sir, it is visible.
Yes, sir.
So good morning to all of you, and thanks for the extensive introduction about me. As discussed with Dr. Gauri, I prepared my slide for the KTB mass extinction. That stands for Cretaceous Tertiary Mass Extinction. Okay, so in the just a minute. So in the slide, the first slide itself tells something about how the dinosaur got extinct. So whether they have got extinct due to wildfire or because of the volcanic eruption or some meteoric impact. We will also discuss about Is the mass extinction was an instantaneous event, or it was a snapshot event in the geology, means taken suddenly, and all the dinosaur and related species living at that time got extinct suddenly, or it was a gradual deterioration of the climate and atmosphere. Because of that, the dinosaur got extinct. Okay, so before the discussing about the extinction, I would like to share some facts about the evolution also. So as we know that the evolution is a natural phenomena, and we can neither accelerate it or not stop it. So it is a perpetual event that goes on with a natural pace. Similarly, a background extinction is also a natural phenomena, and we cannot stop it. So it has been observed in the geological record that generally the species evolve and get extinct after every million years. And this is a natural phenomena. And because of this, this is how the balance and diversity in the rock record or in the biodiversity maintained in the nature. Okay. So now then what is the mass extinction? It is also called a biotic crisis or extinction event. By definition, extinction, it is an episode in evolutionary history when more than 50% of all known species living at that time went extinct in short period of geological time. Okay, so what happened actually? So because of this, the extinction or a background extinction becomes much more higher than the evolution, and that results into a loss in biodiversity that we call a mass extinction. And because of this, a permanent loss of a species or a genus take place, and we lost forever. And a sharp decrease in biodiversity occurs across the boundary. So across the boundary means when we put the boundary between Cretaceous and Tertiary in the rock record, then we find that before the extinction the diversity was high, and after the extinction we see a biotic crisis. Okay. If any of the geological term are not familiar to you, you can ask me at any time. You can stop me. You can ask me. So usually, the mass extinction is related with a large-scale catastrophic event on Earth and subsequent deterioration of the climate. And the climate includes the deterioration of the biosphere, lithosphere, atmosphere, and hydrosphere. Means the loss of the habitat. Means that there is no space for the animal or plant to live, and that's because of that the organism get extinct. Okay. So this is the geological time scale at the horizontal axis, and in the vertical axis there is a loss of percentage of species or genus during the extinction event. So in the geological event and geological record, we observe 5 major extinction. The Kamal sir has told that this is the natural phenomena. The animal get extinct and evolve, and that is also we see in the rock record. So the first extinction event is reported at 440 million years at the boundary between Ordovician and Silurian. This was the time when the graptolite got extinct. Then another extinction, that is between the Devonian and Carboniferous, when the major species of trilobite and bivalve got extinct, as well as the brachiopods. And the most important and most devastating extinction event took place at Permian Triassic boundaries that took place around 251 million years. and this was the at this time the entire trilobite got extinct, and this is the only reported extinction event in which the insect got extinct. As we know that the insects generally lives under the surface, and they can feed on the dead animal parts. They are scavengers. They can live without food for many days. But during this extinction event, the climate was so deteriorated that even insect got extinct. Then we get another small extinction at boundary between Triassic and Jurassic. This was taken place around 205 million years back, when a species of some ammonoids get extinct. And the latest one is the KPG boundary or Permian Triassic extinction event that took place around 65.5 million years. This was the time when the massive dinosaur got extinct. This was the time when the land was ruled by the dinosaur, and the sea was occupied by the ammonites. And the size of ammonites, they are from small to the very big size, even larger than a human size. So they were living in the ocean, and they got extinct completely. And the animal that is living at the land, dinosaur, they also got extinct completely. So we'll discuss about this the Cretaceous tertiary boundary. Okay. But generally, as a geologist, our job is not very fancy data, fancy kind, which you have seen in the photographs. We have to discuss and see the things in the rock record. And the only and the most important help or tools are fossils. But in the nature, the preservation of fossils is not complete and continuous. So whatever the record is available, we have to deal with it. So what are the problems we face in the field are listed here, like period of non-deposition or erosion. Means if we are going in the field and we are targeting that we will look for a rock for 65 million years, but that was the time when there was no deposition. And if the deposition was there, it was later eroded after 65 million years till present. So if we will not get the record, we cannot do anything. The next one is the thrusting of older rocks over younger rocks. So if the rocks get thrusted, folded, faulted, like we see in the Himalayan mountain, then what happens? The law of superposition is disturbed. As we know, the law of superposition tells that the older one will be at the bottom, younger will be at the top, but due to tectonics or mountain building process, all the beds get mixed, and this is very difficult to identify the exact boundary. Then if the poor preservation of the fossils, the fossilization is a very rare phenomenon. Once the animal die, it has to pass through chemical, biological, and physical process of disintegration. Once the animal get past from these events, then only it can get recorded in the rock as a fossils if it get covered by the sediments. So if the fossils preservation is not good, then we cannot date the rocks, we cannot identify the environment or climate. And even if it is preserved, but it is beyond recognition, means it is preserved in a small fragments and is not identifiable up to genus or species level, then we cannot do anything. Then if the animals have no hard parts, the many animals, as we know that many animal doesn't have hard parts, so they are not less likely to be get preserved in the rock record. So that is the one issues. Then bioturbation. Bioturbation is a trace fossils. So animals make a burrow in the sediments, and while doing so, they also mix the fossils that is living in the rock. And if the animal mixed all those important on the targeted horizon, then it is difficult to identify the exact event in the rock record. Then absence of index fossils. Index fossils are those fossils which have hard part. They generally get preserved in the rock record and they have a wide geographical distribution. So such animals are very useful for correlation. And if you do not have any species which are correlatable, then you cannot do the regional correlation. Or if there is no marker horizons of igneous activity or metamorphic events. So we actually need events to date the rocks. If there is no event, we cannot do anything. So this is not only the issue for the poor preservation of the fossils. If the fossils are more, then even we get problem. So there is a case overprinting of event in a single bed that we call condensed section in geology. So I will just try to explain you. If we go away from the shoreline, so what happens? The sediments that is carried by the river is trapped near the shoreline, a shallow water environment. And as we go in the deeper part of the sea, the sediments are supplied less because all the sediment get consumed in the shallower part where the space is available for deposition. So in the deeper part, what will get, you will not get the high rate of sedimentation. Instead, you get the slow suspension setting of the fossils that live in the water column. So in the rock record, what happens? Many age of the fossils get mixed together. And in that case, if you are getting a very high rate of high occurrence of the fossils, even that you cannot demarcate the separate boundaries. So I will try to explain these things with some field photographs. So here, this is the field photographs where you can see there is a limestone beds. These are the limestone they jetted out and fossiliferous limestone. This is around 20 to 30 centimeter, but overlying beds are even a meter thick. But you can also see there are a very thin limestone, less than a 10 centimeter. Okay, and in between there is a shale, which are soft rock, and these are the hard limestone band. So these are the representative condensed section. They were deposited in relatively deeper water, and it is full of fossils. So what happens? We take this sample, make a thin section, and you can see here. You can see my cursor. I am pointing out to my cursor. So you can see the entire limestone is full of fossils. This is a benthic foraminifera called Ammonia populosus, and there are some bivalve fragments. And rest brown color is the micrites, limestone micrites, micritic mud. So you can see the entire thing is made up of fossil only. Then the another, you can see here in this part, the entire horizon is bioturbated. All these things are borrowed vertically as well as horizontally. So entire sediment is get churned off. And if I want to put some boundary along this, I cannot point out because everything is mixed here, but because of the bioturbation. Now the next one is, it is very interesting. Here you can see a lower one is more whitish, a milky one. These are the limestone full of fossil. Is the example taken from the Kutch, Gujarat. And the overlying is also a limestone, but it is little muddy. So what happened in this case, this limestone is, the age of this limestone is 35 million years. That is of Eocene age. Okay. And after the deposition, it was exposed for a 9 million years. So what happened in the hot, humid climate, as the limestone terrain was there, so the crust topography developed. The crust topography is the sinkhole and erosion. And after 9 million years, the another limestone get deposited. And what happened within this cavities, the limestone of younger sediment get filled into the older rocks. So if I wish to make a boundary from this to this, what will happen? That the this whitish limestone is 35 million year old. This just adjacent to it is a 24 million year old. So yes, we wish to wants to use the fossils, but the fossils to be used very cautiously. Whether it is in situ, whether it is transported, whether it is indicating some environment or not, that things are very important. Okay. So sorry, and in between this there was there is a shale bed. So what happens, we take the samples. This is also from the Kutch, Gujarat. So we collect the shale samples from these horizons, and then we take it to the laboratory, we wash it, then we sieve it, and then we see the process sample under the microscope. Under the microscope, you can see they are all in the micron size. The size is given, and then we collect these very tiny particles of even less than a grain with the needles, and then we put into the sample tube, and then we take the ACM, scanning electron microscope photograph. That after that we can see all these features which tells about the environment, salinity, depth, and energy condition of the sea. So out of these globular structures are the planktonic foraminifera. The foraminifera are the protist. They are unicellular, and they generally make the shell of calcium carbonate. These are also foraminifera, but they are larger one. We call a larger benthic foraminifera. Planktic is the animal that float into the surface, water column, and the benthic one is the that dwell at the bottom of the sea. And these rest of them are the smaller benthic foraminifera. They are smaller in size and they are bigger in size. You can see with the naked eye, but these cannot be seen with the naked eye. Okay, so come to the KPG extinction event. That's the Cretaceous Tertiary. So this is the geological time scale. So there is no actually a tertiary time scale. The Earth evolved at around 4.6 billion year or 4,600 million year back, and then the things has been, then the entire period is divided into Hadean, Archean, Proterozoic, and then Phanerozoic. Phanerozoic means the life with hard parts. So that is divided into Paleozoic, Mesozoic, and Cenozoic. So that's why there is no tertiary time scale in the rock record. That's why the people started it to call a Cretaceous Paleogene, a scientifically more correct word. And that happens around 65.5 with an error bar of 0.3 million years ago. And that coincides with the mass extinction. So I have already explained you there was a 5 major extinction: Ordovician, Chaluburian, Devonian, Mycenaean, and then Permian, Triassic, and then Cretaceous and Paleogene. So you can see here the life with hard part is started with 545 million years. Okay, means from this time afterward we get a complex animal, multicellular animal with hard part. So was there a life before that? Yes, life was there. Life was not absent, and you get the fossils from the Proterozoic and even in the Archean. But those life were simple unicellular and in the form of blue-green algae that we see in the rock record as stromatolites. But very close to this pre-Cambrian boundary, 620 million years back, we get a complex life structure, a metazoans, triploblastic animals. That is called the Ediacaran. The Ediacaran is a province in Australia. From here it was first reported multicellular metazoans before hard shell. So that is also a very important observation. So don't believe that the life was not there before Cambrian. Yes, life was there. Mostly it was unicellular, colonial, and and near the boundary, a multicellular life was also reported. Okay, so what happened in this extinction? That dinosaur got extinct, ammonite got extinct. This is the second largest extinction after the Permian Triassic. Half of the life that was living at that time died out. Maybe related to Deccan volcanism and Chicxulub crater. Maastrichtian sea level regression. The sea level was dropped during this time. I will discuss it later. And the tropical groups suffered most. Okay. So before going into the cause for the extinction, I would like to explain who got extinct and who survived and why. In the marine organism, it was highly selective that around 40 to 76% species of late Cretaceous got extinct, in which the chalk forming Coccolithophores, Foraminifera, 83% got extinct, Ostracod 50%, bivalves 70 to 80% got extinct. This percentage is based on the species in the rock record in the form of fossils which were occurring before the boundary and after the boundary, and because of that we calculate based on that we calculate the percentage. Then the planktic foraminifera, 95% of the planktic foraminifera got extinct. Then the sponges around 70%, sea urchins 54%, corals 97 to 98%. Yes, ammonites completely. Marine reptiles 93%, and radiolaria was not affected by this. Why we will discuss later on. Radiolaria is a microfossils, a siliceous microfossils that live below the CCD, carbon compensation depth. This is below 4,500 meter depth. So that below that the environment was not deteriorated, so they lived. They escaped extinction. In the continental parts, the reptiles in general 56% got extinct. Dinosaur, yes, completely killed off. Hair plants 10%, dinoflagellate 5%, placental animals survived. So they survived. Marsupials 9%, rodents, and multitubercles 50%. So in general, on land, anything bigger than 25 kg was killed off. The animal which was less than 25 kg was survived. And all the survivors includes the lizards, snakes, crocodiles, turtle, mammals, frogs, salamanders. So you can see these are the animals which can live on, the amphibians, they can live in the water, they can live in the land, they can feed on the dead animals, they are scavengers, some of them can live inside the surface. So because of this form of life, they survived. So these are the animals which got extinct. The pterosaurus, that is the avian dinosaurs got extinct. The plesiosaurus, that the animal which live in the marine environment, got extinct. The ammonites, the extinct completely. And dinosaurs, yes, they got extinct completely. Okay. So very interesting things that I would like to explain here about the nautiloids and ammonites. So these nautiloids appear, and they both belongs to cephalopod. They are the groups of classes of cephalopod. So nautiloids, ammonites, and acolytes. All out of these three, the ammonite got extinct, but the nautiloids and acolytes are still living today. And very interestingly, the nautiloid appeared in the Cambrian, and then Cambrian, and they lived up to the they are still living. But ammonites that appeared in the somewhere in the Permian or Carboniferous, they evolved very rapidly in the Jurassic time, Triassic Cretaceous time, and got extinct in the late Cretaceous event. Why? Because these are the first animal in the rock in the fossils record which can swim vertically in the water column, and they have a good uh, escape escape mechanism from the threat. They have the ink sac, they throw in the water columns to blur the water, and then they escape from the predator. But how they got extinct? This is related with their embryo. So their larva, the larva of the nautiloids actually grow in the bottom of the sea. When they become a juvenile and mature, then they come to the surface and live. Whereas the ammonites larva develops at the sea surface, and then they grow, and then they swim in the all water column. So during the extinction event, the surface water was most deteriorated because of the acidification of the sea water, and as the larva was not survived, so the entire species got extinct. So the survivors were mammals, birds, turtle, crocodile, lizards, amphibians, bony fish, sharks. Okay. So I have discussed about the who has got survived, who got extinct. But what happened after extinction? The bivalve and gastropod family took around 20 million years to recover the late Cretaceous diversity. Means their diversity was get delayed by 20 million years. Similarly, the planktonic foraminifera, calcareous nanoplanktons, dinoflagellates, they took 10 to 15 million years before pre-extinction diversity. Similarly, each species and groups required 2 to 3 million years to get the previous diversity. So in general, all species was delayed by 10 to 15 million years in re-establishing the Cretaceous level of species diversity. Now we'll discuss about the cause for the extinction. So there are the two hypotheses. The one explains about the extraterrestrial event. So extinction was extrinsic, means the extraterrestrial nature or some catastrophic events took place. So there is a chemist of Luis Alvarez and his son Walter Alvarez is a geologist. So they proposed a hypothesis that there was a meteoric impact at the Cretaceous tertiary boundary, and they proved this with the help of occurrence of iridium layer at that time, and that iridium was recovered from almost every part of world. We know that the iridium concentration of iridium in the crust is very less. It is around 0.3 ppb part per billion in the crust. But at particular horizons, we observed a 445 ppb, and this iridium is very common in the meteorites. So based on this observation, they proposed their hypothesis. For that, they also get the Nobel Prize. And they explained that the hypothesis explained in a way that the meteorites have impacted. Because of that, the cloud was ejected into the atmosphere, and the sunlight was blocked. So photosynthesis disturbed. Entire food chain was destroyed, and so the animal got extinct. So what are the evidences for the meteoritic impact? Yes, I just told you the iridium was found in many sediments of the Cretaceous. Iridium is a metal that is rare in Earth crust, except in the interior, but it is very common component in the meteorites and asteroids. So based on that, they they explained the meteorite impact. Later on, the exact crater was also discovered while searching for the hydrocarbon or oil exploration in the east coast of Mexico through seismic survey. So because of this impact, we also get the shock quartz. Means generally these are all the minerals have some crystallography, but because of the high temperature and pressure, because of the collisions, their crystallography was disturbed and melted. So you can see this is the shock quartz, photograph of a shock quartz. And acid rain took place because the sulfur was ejected into the atmosphere because of the impact, and temperature was raised. Because of the temperature, the wildfire took place, and because of this wildfire, the carbon was in the surface crust was available, that in the form of soot. So you can see the carbon globules that is recovered from the KT boundary layers. Okay, so where is the craton? It is a 10 to 12 kilometer wide size asteroid or comet impacted on the Yucatan platform and formed a crater of a diameter of around 180 kilometer. So yes, 180 kilometers. So if a 10 kilometer diameter object impact at the point at which it struck, it would have a velocity of around 1 lakh kilometer per hour. So the 10 to 12 kilometer meteorite impacted on the shelf of the Gulf of Mexico, that is the Chicxulub crater, and with a speed of 1 lakh kilometer per hour. So what is the magnitude of the impact? The KPG impact resulted in 100 million year megatons of energy. That is the equivalent to the energy of 300 million nuclear weapons together. This much energy was released because of the impact. And we have a direct evidence of the crater still present in the offshore of Mexico. Because of that impact, as the impact landed at a low angle, around 30-degree angle, it ejected the massive amount of sediments and minerals into the atmosphere. As well as because of this collision, this is the site where exactly the meteorite impacted. And because of this, around 500-meter high tsunami wave was generated. And this is observed in the around 1,000 kilometers away from the impact site. So these sediments has been studied, and the age of the sediment is correlated with this event. And because of this energy, the fire has taken place. Okay, so the earthquake with a magnitude of 10 to 12 Richter scale, actually in the earthquake Richter scale, we have only 10 up to 10, but it was more than that. So global wildfire based on the presence of the charcoal and polynuclear aromatic hydrocarbons is found near the boundary clay. So it is not, and as well as it was at the shallow shelf. So the shallow shelf is known for the deposition of gypsum. Chemical composition of gypsum is CaSO4 means once the gypsum is ejected into the atmosphere, means the sulfur was ejected into the atmosphere, that led to the acid rain. So what happened because of this? The cloud was the massive cloud was distributed to the upper atmosphere, and this because of the wind, the global wind, it was circulated all around and it blocked the sunlight. And it took around 10 to 12 years or 15 years to dissipate this cloud. But within this 10 years, your vegetation was died because the sunlight was not coming, photosynthesis was closed. So primary producer of energy or food was collapsed. So the entire food chain was disturbed. Even it also related with the accident because the sulfur was ejected and the amount of sulfur and methane gas was available in the atmosphere, which affected the greenhouse gas, and because of the impact and energy that is released, that led to the wildfire. So the important thing is that the food chain was collapsed, so the animal got died. Okay. So small pause. If you have any question up to this, you may ask. I will go to the next part of this presentation.
Thank you, sir, for enlightening us with your deep knowledge on Cretaceous mass extinction. So we have few questions from the audience. Sir, with your due permission, may I take those questions?
Yes.
Sir, what do you think are the main factors explaining almost full absence of fossil record in tropical Africa during the Mayo-Pliocene age?
So the Mayo-Pliocene is was a time when the Messinian salinity crisis took place. It is related with the closure and opening of the Mediterranean Sea. Because of that, we get a very less amount of fossils record in the Pliocene. Even if you see in India, you have no record of Pliocene sediments. They are mostly because of the large scale sea level regression.
Thank you so much, sir. So next question is, can we opt for the geology as a career if we are from life science, botany, or zoology?
After doing graduation?
Yes, sir.
No, I don't think. That's you need to have a bachelor degree to take the master degree in geology.
Thank you so much, sir. Sir, Ankur is asking, is there any significance behind the name of the geological time periods?
Yes, I will explain.
Okay,
or,
sir.
Or should I explain it now?
Sir, okay. It's your call.
Okay, no issue. See, can you see this? The name of these periods of the geological time is related with the either place or either peoples, like the Permian. Permian is named after Perm province of Russia. Okay, Jurassic is named after Jura mountain of Switzerland. Okay, Ordovician is a tribal in the Wales of England. Cambrian is a province in England. Okay. So similarly, the entire name is given. Yeah. So we name the period or time based on the place or based on the population. Like we call the Gondwana land. Gondwana land is named after the Gond tribe of India, Central India.
Thank you so much, sir. So next question.
There is a Khonda light rock. The Khonda light rock is named after the Khond tribes of the area. Those live in the Orissa. So based on that, we name the rocks, either place or people.
Thank you so much, sir. So next question is from Arushi Dogra. She's asking, are there any traces what led to the extinction of the Jurassic period, or we are still assuming the reasons?
No, we are not assuming the reason. Don't believe like this. We are doing, we are, these are all a documentary kind of thing, that cartoon kind of thing to make you convinced. But all the data is based on the rock record. We are getting the fossils of dinosaurs at that time. We are getting the iridium layer of that time. We are getting the shock quartz. We have already identified the exact impact crater that is lying in the offshore of Mexico. So that is not the blind hypothesis. This is all the supported with the fact.
Thank you so much, sir. So next question is from Ansh Sharma. He's asking, what events testify approach for natural extinction and what measures should humanity take to minimize its harm? Adding to it, a student is also asking, sir, are we moving towards sixth mass extinction? How can we avoid it?
What was the first part of the question?
Yes, sir, I'll repeat it. So the question is, what events testify approach for natural extinction and what measures should humanity take to minimize its harm?
Okay. So I must say you that the change is the only law in nature which never change. Okay. So extinction is a natural phenomena, and the evolution of life or extinction of life is took place in a very long period of time, and human lives are very small with respect to judge this extinction period or evolution period. We only rely on the fossils that is available to us. We cannot stop extinction. We cannot not accelerate extinction. We cannot stop evolution, accelerate evolution. Yes, what I mean, we cannot we cannot exaggerate or expedite the process of extinction by killing the animals, but that is also not in control of the human beings. That is the secondary phase. Humans cannot do the things which at the scale where the nature operates.
Thank you so much, sir. So the next question is, what is the best method to stop?
Whether this answer was sufficient or not?
Yeah, sir, it was a very satisfactory answer. Thank you so much, sir. So next question is, what is the best method to stop pyrite decomposition of a fossil?
Pyrite?
Decomposition of a fossil.
Decomposition of a fossil?
Yes, sir.
I mean, this question is not clear to me. Decomposition of fossils means what?
Okay, okay, fossils are... I'll ask the student to rewrite it and I'll ask you again, sir.
Yeah.
So the next
because
question
the fossils lie in the natural environment, and they get preserved after all those dissolution and fragmentation and all these things. So this question is not complete, I think.
Okay, sir. So next question is from Devang Singh. He's asking, so pseudo fossil and molds where organic matter is lost and just replica of organic remains are not exactly a true fossils, yet they are discussed thoroughly. What information can we extract from both of these?
Oh, good question. So see, the fossilization process is very rare. If you go to the field, you people doesn't get the fossils everywhere at every time, and many times the important fossils are not available to us. So whatever the fossils are available in whichever form we discuss. Okay, we have a very extensive branch for the trace fossils. In the trace fossils, we discuss the traces of the animal, in which the organic part or even we don't know the precursor of the animal who created it. But though we do the trace fossils for getting the information about salinity, temperature, depth, who made it, what was the whether the substrate was hard or soft, all those informations. We have the very extensive branch for the trace fossils. So we use all sorts of information, whatever they are available. Only that they should inform us about the behavior of the animal. I can just give you the example that if the animal is walking on the soft sediment, then their footprint will be formed. That can be taken as a trace fossils. But if the animal is dead and its hard shell is rolling over the soft sediment and making some structure, that is not considered as trace fossil because that is not giving any behavior activity of the animal. So the any
Thank you so
information, yes, so that we use. Okay.
Thank you so much, sir. So sorry to interrupt you. Thank you for the satisfactory answer. So next question is from Tripti Rawat. She's asking, so which extinction is considered as the largest mass extinction in Earth's history?
Yes, that is the Permian Triassic. I already told you. Permian Triassic extinction is the largest and most devastating extinction event that took place at the boundary of Permian and Triassic, 250 million years back. This was the event in which the 90% of the animal living at that time got extinct. This was the extinction event when the insects were also killed off. Nothing was left after the extinction, only few were able to escape the extinction. This is also called as mother of mass extinction.
Thank you, sir.
Yes.
Sir, so the next question is, sir, to determine the exact or near exact age of any fossil, we use radioactive dating and generally we use carbon-14 dating as a reference. But it have a half-life cycle of 5,730 years and it can be used to determine age of fossils up to 70,000 years. What about
that? Yes.
What about fossils of much older time?
Yes,
is there
yes,
any
yes,
method to determine
yes,
fossils
yes,
age except radioactive dating?
Yes. See how we determine the age of the fossils. Okay. So generally, the fossil doesn't give the age. First of all, I must tell you. Okay. The fossils give the material which can be dated. Okay. In general, we don't consider a carbon-14 dating for the in the geology. We go for the radiometric dating by strontium, lead, uranium, all those long stable isotope material that can be dated. Fission rate dating, some other dating. So we go first. We date the rocks with the help of a stable isotope, or we can also date the mineral orthogenic minerals that has formed during the deposition of the sediments, and then we go for the biogeochronology. Biogeochronology is the correlation of biology and chronology. So once, as we know that the evolution is in unidirection, once the animal get evolved and when it get extinct, it will never come back. Okay, so based on these principles, we identify the species. Once we get the date of this species, we use at the independent reference material for correlation. But before using it, we must date it, and we date it through the stable isotope. We generally don't use the carbon because it is very less, only 5,000. That is not applicable in geology. 5,000 is nothing, less than a second in geology.
Thank you so much, sir, for satisfactory answer. Sir, so the next question is from Harsh Sharma. He's asking, so what's the reason for the extinction of marine species at that time?
So that I will discuss. No issue. You can ask same question after I complete this.
Okay, sir. With your due permission, I'm moving to the next question. So the next question is from the Suryadev Singh. He's asking, sir, as you said that all plants died during the phase of the blind huge wave due to the restriction of sunlight, then how the plants grew again post-extinction, especially plants who require a predominant request for its growth like seed or fruit?
So this many of the plants, I told you that there was a no complete, if you go for this data, plant were only affected by 10%. You can see only 10% of plants were got extinct forever. Okay, rest were survived. Okay, so that it was not complete. It was not complete extinction of the plant animals. Yeah, if the animal get extinct by its odd seed and plants, then we cannot retract back. That is true.
Thank you so much, sir. So the next question is from Shivam. He is asking, how did paleontologists visualize based on the fossil, even the fossil is teeth or bone? How did paleontologists visualize organism based on the fossil? I'm repeating the question. Sorry, sir. So the question is, how did paleontologists visualize based on the fossil, even the fossil is teeth or bone?
Okay.
So this is the question. I guess it's an incomplete question, but he has
No,
asked
I
this.
think he is asking that he is asking about the vertebrate things. Yes, in the vertebrate, what happens when the animal get die, and then and their all ligaments get disintegrated, so that they all the bone fragments disperse throughout.
Okay, sir. So these are the questions which are for your talk. Sir, now you can move ahead, sir. Sir, am I audible to you? Uh,
Yes, Vikram, you are.
I guess sir is not co-host now. I request Gauri ma'am to make sir co-host again. Ma'am, are you there?
Vikram sir is co-host.
Sir, you can unmute yourself.
Okay. Yes.
Yeah.
Hello. Now I am
Yes, sir.
audible.
Yes, sir. Yes, sir. Yes, sir. Audible, sir.
Okay.
Yes.
So what was the question?
So you were explaining the last vertebrate thing. So the last question was,
Yes, yeah. So yeah, so we need a convincing part of the fossils to explain. Only a piece of the fossil cannot tell everything. That is true.
okay. Thank you so much, sir. So these were the questions from the audience. Now I request you to move ahead with your talk, sir.
Okay. Thank you.
Thank you, sir. Thank you, sir, for patiently answering all the questions, sir.
Mm. Okay. So is the slide is visible?
Yeah, sir, it's visible.
Okay. So now I'm continuing the second part of it. So the people's belief that the
Sir,
meteorite.
sorry to interrupt you. Actually, it's not presented
Yes.
yet. Sir, kindly present your screen. It's not presented yet.
Okay, just a minute. Now it is.
Yes, sir. Sir,
Yes, sir.
yes,
It's visible,
slide,
sir.
slide is visible. Sir. Thank
Okay.
you, sir.
Okay. Okay. Thank you. So people believe some people believe that the impact of Chicxulub was the cause for the extinction of dinosaur and ammonites. But that is not true because it was in the northern hemisphere. It cannot wipe all the species living at all places of the part. So here you can see this is the present configuration of the sea and land, means the present global map of today. But it was not true for the Cretaceous time. During you can see here in the bottom of the screen, this is the configuration of the land and sea. And at that time, the India got separated from the Gondwana or Africa and Madagascar and started moving towards north. So there, and it was not still collided with the Eurasian plate, and there was no Himalaya and there was no Indo-Gangetic plain. It was just a triangular shape, and while moving, it crossed over the reunion hotspot. Reunion hotspot are the volcanic capes, volcanic cones that are stable. We believe it is stable. So if the crust will pass over it, it fractured the crust of the India, and lava erupted to the surface. And when it passed over the reunion hotspot, then it was releasing the lava in the sea, and you can see the trail of volcanic cones in the bottom of the sea. So that was the reason for the volcanism in India, and it took place near the Cretaceous tertiary boundary. Now you can see this was the red circle indicates that the area that was affected by the volcanism. So almost entire India was affected by the volcanism, and there was no space to live for dinosaurs. So it was an 1.5 million year square kilometer area was covered by this volcanism, and volume 1.2 million cubic kilometer lava was erupted because of this volcanism. And we know that the temperature of lava is around 900 to 1100 degrees centigrade. So now you can imagine, and thickness, that's the 3000 meter thick lava erupted, and entire duration was 5 to 7 million years. Oh, that is quite okay. The 5 to 7 million year continuous lava was flowing on, no issue, but it was so. So imagine that something as 3000 meter thick lava with a temperature of 900 degrees centigrade was there nearby you. Will you be able to survive? Let's see. Okay. So when India got passing over the reunion hotspot, the Deccan volcanism took place, and the entire phase of volcanism was in three phase. So phase one, only 6% of lava erupted, and this C29A is the magnetic anomaly date. Okay, so this is a magnetostratigraphy. So when the lava get cooled and solidified, then their iron bearing mineral get oriented according to the prevailing magnetic field of the earth, and we know that the magnetic field of the earth reverses through time. So based on that, we date the rocks. So that was around 67.4 million years. But the second phase was most devastating. Most devastating. Almost 80% of the lava emanated, and it was C29 reverse, the magnetic polarity. And it was very, very close to the Cretaceous Paleogene transition. Yeah. Is I'm audible now?
Yes, sir. Yes, sir. The
Yes, sir,
screen is
you are
also
audible.
visible.
Okay. I think the technical complication is now starting. Okay, so this the phase 2 that released 70,000 gigaton of SO2 in the atmosphere, 35,000 gigaton of CO2 released to the atmosphere, and that was almost 200 times more than the Chicxulub crater impact. Other than this, the vast amount of vapor, HCl, HF, methane got released to the atmosphere. And because of this, they prevented the ecosystem recovery. Means all those are either greenhouse gases or led to the acid rain. So what happened because of this Deccan eruptions? So mostly this gas SO2, Cl, F, NH2 emissions, CO2 emission, thermogenic gases, and including methane get released, and they all led to the either ozone depletion, ocean anoxia, acidifications, global warming, and it is estimated that the terrestrial temperature was raised by 8 degrees centigrade, whereas the marine seawater was raised by 4 degrees centigrade. Because of this, the extinction took place. Okay. Now my next part is based on other evidences of the mass extinction. Means, is the mass extinction is a instantaneous event, or it is a gradual deterioration of the climate. So see the multiple impact, simultaneous multiple impact, like a Baltis crater that size is around 24 kilometer in diameter impact is identified in Ukraine, that is also 65.17 million years back. Silver Pit crater 20 kilometer wide diameter in North Sea, 60 to 65 kilometer. Some of you may have remembered that the collision of the comet Schumacher-Levy 9 with a Jupiter in 1991 showed that such a multiple event can take place in a few days also. So this is the last month news, the symbolic photograph that the asteroid named as 2001 F032, sized 680 meters, passed away just around 20 lakh kilometers away from the Earth with a speed of 124,000 kilometers per hour. So the meteorite passing or meteorite shower or meteorite impact is not an unusual phenomenon. It happens. The peoples are now trying to divert the path of the meteorites through a missile or to destroy it with the nuclear weapon. Okay. Now the question the student had asked, that the Maastrichtian mass sea level regression means the sea level fall. Regression or the drop in sea level most likely is the mid-oceanic ridge become less active. We know that along the mid-oceanic ridge, where the two plates move away from each other, the lava comes out. But this activity is not take place at the same pace. So sometimes it is very active, sometimes it is less active. When it is less active, it cools down. As it cools down, because if it's on wet, it subsides. When it subsides, the more space is created and water come towards it. Because of this, the shoreline should move towards sea. So the shoreline regression or drop in sea level is observed. So this was the largest sea level fall in the Mesozoic time in the late Cretaceous. And we know that the 90% of the animal lives in the shallow water within the photic zone. Means the photic zone means the light that can penetrate into the sea, and that is up to 50 meter bathymetry. Depending upon the clarity of the water, it can go up to 100 meter also. But the 90% of the species live in this environment because the food production, photosynthesis took place in this part. So either you are carnivorous, herbivorous, you have to take the food from the herbivores. So once the sea level got recede, the animal get exposed. They cannot track back with the sea level regression. and the animal got died. The most of the shallow marine animal got died or got extinct. So in the large igneous province of the Deccan Trap, along with associated climate and environmental change, is played a significant role in the in-mass Cretaceous extinction. But the single large asteroid impact could not have been the sole cause for the in-Cretaceous mass extinction. Rather, was a contributing factor. However, multiple impact or comet shower is most rational explanation for the long-term biological, environmental, climatic change that leads to the extinction. So, I'm for last for more than an hour. I am talking about extinction and extinction, but extinction is not a bad. The dinosaur got extinct. That's why the human got evolved. The ecosystem was available for the cattle, and later on the humans evolved. Thank you.
Thank you so much, sir, for enlightening us with your deep knowledge on Cretaceous mass extinction. So we have few more questions. So,
Just
sir,
a
with
minute.
your due
Just a minute.
permission. Okay,
Just a minute. Vikram Kamlesh. I'm just Dr. Vikram. I'm just wants to share a video. Okay.
okay, sir. Sir, please go ahead. And sir, I'm a student of BSc Life Science, sir.
Okay. So just a minute. Once I. Hello, Vikram. Is my slide screen is visible?
Yeah, sir. Your screen has started screen sharing. Yeah, video is visible, sir. You just have to play it, sir.
Okay. Is it audible?
No, sir, it is not audible yet, sir.
Hmm?
No, sir, it is not audible, sir.
It's not audible, sir.
It is not audible.
No, sir.
Yes.
No, sir.
So how to make it audible? I don't know. Is the voice is volume is full? Now?
Yeah, sir. It's audible now. It's audible.
Okay.
Yes, sir.
Just minute. So I am making it starting with. Okay.
70,000 kilometers per hour. Times acceleration equals force. As the asteroid encounters atmosphere, friction turns it into a body. It takes just 4 minutes to cross the Atlantic Ocean on its way towards Mexico and the Allosaurus. As it travels, it crushes and superheats the air surrounding it, turning gas and debris into white-hot plasma. At around 20,000 degrees Celsius, it burns many times brighter than the surface of the sun. It takes just 5 seconds to flash through the atmosphere. Seems instantaneous. This cataclysm is a series of discrete events invisible to the naked eye, but key to understanding what follows. The asteroid's trajectory is shown. It flies in at around a 30-degree angle to the surface. This means that the full brunt of its destroying power will be thrown forward a few grams. Its brightness in the sky is unimaginable. From the impact site, the light is so intense it causes the flesh of the Allosaurus to appear transparent. It burns images of their shadows onto the ground. The scorching light sears their eyeballs. They now can't see what's headed that way, but they can feel it. The asteroid hits with an explosive force of 100 metric tons, more than 1,000,000 times the power of the bombs dropped on Hiroshima and Nagasaki. If the asteroid had crashed into the ocean, some of the force would have been absorbed. Instead, it hits the shallow waters of the Gulf of Mexico, which instantly vaporize. In a fraction of a second, the entire asteroid disintegrates into the planet. Earth and rock hurled skywards at 160,000 kilometers an hour. Behind them, more than 300,000 cubic kilometers of the Earth's crust explodes from the ground. 800 kilometers from the crash site, the air temperature reaches 300 degrees Celsius, so hot that the water in the dinosaur's skin melts, escaping in bursts of steam. The fiery blast sucks every drop of moisture from the surrounding vegetation. Anything directly exposed to the blistering heat is simply burned alive.
Thank you, sir, for enlightening us with your
Just-
deep knowledge.
just मत let me also, क्या हो गया ये इसको ऑफ करना पड़ेगा ना. Yes, how to go out of this? I have to go to there.
Sir, just stop presenting your screen.
Okay.
Go to the Zoom tab and stop presenting your screen, sir.
Mhm. I think my screen just
Yes, sir, you are not presenting.
okay. Okay.
Sir, may I take few questions from audience with your due
Yes.
permission?
Yes.
Yeah. So, so this first question is from a student, and he's asking, sir,
Mm.
how episodes of large igneous province LIPs and be confidently linked to the occurrence of ocean anoxic events, biological consequences like mass extinction or ocean metal anomalies. Is all this purely hypothetical or based on sound scientific evidence?
Mm. So basically, it is based on the study of the rocks. If you go to the Khandala, Lonavala, Mumbai, Pune, these are full of the lava's flow. And you take the basalt, you go for the geochemical study, you will get that how much the lava sediments can hold sulfur within it. And based on their petrographic study and microscopic study, you can also calculate how much this sulfur was ejected during the volcanism. Once the sulfur get ejected, it will come to the back to the surface through the acid rain, and this acid will go to the sea. So that will lead to the acidification of the sea. So the acidification, if the sea is acidified, it will also be confound with the shells from the marine animals. So it is not the hypothetical. This is all based on the true science.
Thank you so much, sir. So
Mhm.
next question is from Sujal. He's asking, so what are the technology developed till date to tackle the impact of the meteoroid if it has some direct impact with our planet in near future?
Maybe we can divert the path of the meteorite by targeting it with the missile or destroying it with the nuclear weapon. The people are doing so. And this is common that every 10 lakhs of year some massive meteorite impact take place on Earth.
Thank you, sir. So the next question from a student is asking, sir, how can we estimate speciation and extinction rates for incomplete phylogenies?
Incomplete phylogeny means?
Sir, basically, it's a chart depicting the phylogeny of species or organisms.
Mhm. So incomplete means if the animal is got extinct. Uh, so what is the true sense? The incomplete phylogeny. I'm not getting actually. Sorry.
Sir, I'll ask the student to again rewrite the question and I'll get back to you. So the next
Mhm.
question is from Devang Singh. He's asking, sir, on the basis of the fossil records, how
Mhm.
paleontologists determine the behavior of organism living million years back? Like it
Mhm.
said, early humans were not that social, and X
Mhm.
animal choose Y food to eat or something else.
Mhm. So that's the behavior of the animal that we study with the help of the where they live, what is their life mode of life, whether they prefer to live in the soft sediment, whether they wish to live in the hard substrate or the vertical position or inclined position. All these things are based on the fossils record. That based on that we identify their ecology, their behavior, and uh, and their food habit, their salinity tolerance, their bathymetry. That all we do with the fossils.
Sir, adding to the question, Devang
Hmm.
is stressing and he's asking, so this may be off the topic, but if possible, please answer. Like humans believe in God existed once and that too on earth. Epics like Ramayana and Mahabharata have shown to have proofs as well. So I just need to know if early man came first who didn't know a thing about wheels, fire, tools, or goods like Ram, Krishna, who already are aware of everything above. I asked because data I found on various platforms does not matches. I really wanted to ask this to someone from way back to get an answer from someone.
Hmm. So, but
So basically, he has, linked this paleontology with mythology. So he's stressing to ask this question from you, sir.
So what he exactly wants to that the early man was not able to.
Sir, his question is like, if early man came first, who didn't know the things about wheels, fire tools or
Mhm,
goods, as per
mhm,
the this file paleontology and all.
mhm,
But he's
mhm,
saying that in the epics like Ramayana and Mahabharata, they have shown the proof as well, like
mhm,
Rama, Krishna, who already are aware of the everything above.
mhm.
So he's also explaining. I
So
asked
okay,
with
I
this
got it.
data.
I got it. I got it. So what do you think that the age of the humans? Humans came around 10,000 or 10 lakh year back. Matlab, earliest humans came in the 10 lakh year back. The modern humans 10,000 year back. Your Ramayana is a 5,000, 7,000. So I don't think to be answered it to link it with. Okay,
Okay, sir.
earlier man was very much early than the Ramayana and Mahabharata. Ram and Krishna was not the first person to come on the earth. Hmm.
Thank you so much, sir, for satisfactory answer. So the last question is from a student. So he's
Hmm.
asking, what do you think about the danger of the solar protuberances to the Earth species diversity?
Earth's total brings over Earth species diversity.
Yes, sir.
Solar, solar.
Protuberances. So
Okay,
basically the
yeah.
solar waves and
Solar
yeah,
flares, solar waves. He is
true,
talking
sir.
about.
Yeah,
Yeah.
yeah, sir.
So basically, solar flares or the activity at the solar surface is not exactly the same. It changes. Sometimes the solar radiation become more active, sometimes less. Sometimes you get the more heat energy, and sometimes less. That is based on the activity that take place in the solar energy. So that based on that, your climate may change. If the climate change, then obviously the evolution and life will also get affected.
Thank you so much, sir, for satisfactory answering all the questions. We are done with all the questions. Now I would like to call Dr. Gauri Nandi ma'am to give official vote of thanks and to conclude the event. Over to
Vikram,
you, ma'am.
Vikram, I
Yes,
want to ask one question from Dr. Pramod Kumar.
Yes, sir.
yes.
Sir, thank you for such a fascinating talk. You made the thing so simple and presented in such an interesting way. There are some of the very, very basic questions out of curiosity. Like, recently I was in the Karabi Island and I could see there was a rock and it was full of barnacles. So were they the remains of the shells which were there, or were they fossils? How do actually know if they're fossil or they were the dead shells or like this? Because I see there was a rock, a cave sort of a thing was there, and there were millions of barnacles were there, sea barnacles. So were they the fossils or the shells of recent barnacles?
Okay. Okay. So basically, for answering this, I must explain about the fossils. And what is by definition, the fossils are the animals should die naturally and should get preserved in rock record naturally. Okay, and after a time when the people identify them or dig out from the subsurface, that is called the fossils. The meaning is that the fossils should always be free from human interference. We cannot make a fossils in the factory. Anything which is interfered by the human will not be considered as fossil. So probably what you have seen is recent shells. But
Okay,
you also get the barnacles in the rock record. So whether it was a recent shell or rock record, that can be confirmed only when you can correlate it in the surface, whether it is old or young.
And sir, one more thing is there, especially when we talk about the fossils, let me confess, I saw fossils for the first time when I go in Italy for a conference, and they have beautiful natural history museums there I could see fossils. Recently, I saw one fossils of Archaeopteryx in the Oxford. Then I could see some of the fossils. Maybe some religious sentiments are attached with these fossils. There is a temple in Jammu, Raghunath Temple. And they have all the Ammonites, a lot of Ammonites, and they say this is the Chakra Gada and
Shaligrams.
Shaligrams. So there I saw the fossils. Then after that, I saw the fossils in your department in the Antradhavani. You have your stall, and there I see the fossils. But unfortunately, the exposure, like I'll tell you about the students. What are there? Nearly good 100 students are there. How many have actually seen a fossil? So are there the places in India or
you want to see the fossils in field?
Yeah, first of all, in museums, and second thing is naturally, I will love to see fossil. If I want to see a fossil, where I have to go, and how will I actually make out the fossil is there?
Okay, so if you want to see the fossils in the field, you can go to Kutch, Gujarat.
Kutch.
Okay? Kutch. That's there you will see the fossils in the field. Okay. And then next you can go to the Kaveri Basin. That is in the near this Chennai. Okay.
But then there should be some expert with me, otherwise I won't be able to.
That is okay. Yeah, that is true.
And second thing is about when we talk about microfossils, for example, protozoan fossils, foraminifers, so like this. It's a rock ultimately you get, and then you go the processing, as you say, slicing or chemical treatment, and then you finally get some of the foraminifers, which are actually microscopic. So they're the characteristic feature of rock, because any piece of the rock you won't be carrying. You will be
I got it. So you means if you cannot see in the field, why you are collecting the sample?
Yeah,
that is the exact question.
Yeah.
So basically, that basically it based on the experience. When we see the rocks, then we assume that this part of the section or this part of the rock must be deposited in some deeper water, and then we collect the finest shale part and mud part of the sample, and we go for processing. So yes, in the field, no one can say it will contain a fossil because it cannot be seen with the naked eye. That is true.
Yeah, but I've seen some of this foraminifers or radiolarians. They're so beautiful, and the slide what you have shown.
So that what I have shown in my slide, I was collected personally collected by me. I have processed it.
That's yeah. Thank you, sir. Thank you.
So even I wanted to ask a question.
Yes.
Sir, have you heard something of Grand Canyon and the Smithsonian Institute?
Yes.
So, because my father has got a booklet and a photo and a very big map. When he was in California, he had gone there. So he had gone to the Smithsonian Institute also, and he had visited the Grand Canyon. Sir, it's I will definitely get in touch with you. It's a beautiful, there in the lower I think the basement rocks only. There are many temples, like Shiva temple is there. Then Vishnu basement rock is there. So what is all this? Because is it possible that the civilization, the Hindu civilization, because there are all gods of India, our culture was there. So can you put some light on that? Because they're all Indian gods and goddesses there. The rocks are named on their names. What's all that, sir?
Maybe a people's many Indians are living in that US, so they have.
No, but very no, sir. It would be way back, because they have closed the Smithsonian Institute for the Indians, and because initially it was open, but now they have closed it for many years. So anything they want to, maybe our like we were there and the culture we have migrated. Any kind of light can you put on this?
No, then I have to look for it. So what actually why they have closed it, and how this statue of those Indian gods are there. That
proper temples are there, sir. Proper temples. The rocks have been named on all our gods and goddesses, and I can click a photo and send it to you. So and now they have stopped, and there is lot of research going on, but they're only involving Americans. No Indians are involved there. So
maybe
my father was
Just send me few photographs. I will try to.
Yes, sir.
see.
Definitely, I will. I
Mm.
will, sir. I will definitely do that, sir.
Okay. Okay.
Thank you, sir. Thank you.
Thank you. Thank you.
Yes.
Now I would like to request Gauri ma'am to give an official vote of thanks and conclude the event. Over to you, ma'am. Am I audible, sir?
Yes, you are audible. So before the Dr. Gauri is coming, I will just share the paleontological newsletter. Dr. Kamal sir, I'm
Yes,
just
sir.
sharing.
Yes, sure, sir. Please do that.
I'm just sharing that. Is it my screen is sharing? I'm just opening the.
Yeah, screen is sharing, but I can see the three icon. One is of course Delhi University Paleontological Newsletter, but it is not open.
I'm just opening it. Now it is open? No.
Not yet.
Not yet. Okay. Mm,
Yeah, now it is open.
okay.
Yeah.
So that this I will share with you. I will share with the Dr. Gauri, and then she can share with you.
Oh yeah,
So
that
that,
would be great.
so this is here you will get the almost, I think you will get all the answers, and this is very brief about basics of geology, paleontology. So here we have just a minute. Okay. Historical development, early multicellular life, trace fossils, Cretaceous, Paleogene, boundary mass extinction, recent significance of fossils in India, historical long-necked herbivorous, then so geoheritage, then PTB boundary in India, everything is there. So I will share it with Gauri, Dr. Gauri. Okay.
Thank you. It is great.
Yes, sir. Thank you, sir.
Okay.
Yes, sir. Thank you, sir, for the enlightening talk, sir.
Mm-hmm.
Sir, thank you, sir, for educating us about the insights of the events, occurrence, investigation, and details of the organisms which survived the KT mass extinction. The video you shared was very interesting and showed us the positive side of the extinction, which was
Gauri, you are not audible.
so is it okay now?
Yes.
Yes, yes.
Sir, yes, sir. Sir, on behalf of the organizing team, I feel apologetic as Professor GVR Prasad could not deliver his lecture due to some urgent work, but sir has given us the word that he will be surely meeting us in the next semester. Gratitude is one of the last articulate of the emotions, especially when it is deep. So we have reached the end of the majestic lecture and great interactive session. This is not the end, but the beginning of the numerous glorious events. Today, I, Dr. Gauri, on behalf of organizers, take the opportunity to put my gratitude into words. First of all, I would like to thank the Almighty for making the today's events a great success. On behalf of Department of Zoology, Deshbandhu College, University of Delhi, I would like to extend my heartiest thanks to our honorable speaker,
I think there is a network issue, sir.
I'm getting disconnected. There is some internet issue, I guess.
Don't worry, you can
For
repeat.
taking out time from his busy. Yes, ma'am.
No, please go ahead. Sorry.
Yes, ma'am. There is some network issue at my end. Um, so I'm very, very thankful to Dr. Pramod sir for taking out time from his busy schedule and enlightening us with such a deep knowledge on mass extinction and answering all our questions. And we have learned a lot from you, sir. I wholeheartedly
Be in
thank our
brief.
principal, sir.
Be in brief.
Yes, sir. Yes, sir. I wholeheartedly thank our principal, sir, who is a dynamic personality and inspiration for all. I also extend my acknowledgements to Dr. Aditya Saxena, Coordinator IQSC, Dr. Indrakant Singh, Coordinator DBT Star College Scheme, Dr. Varsha Baveja, Teacher in Charge, Department of Zoology, Dr. Manisha Sanger, Coordinator BSc Life Science Program, our esteemed faculty members of Department of Zoology for their constant support and guidance. To thank Dr. Monica Bajaj of Computer Science Department for the technical help and all the student volunteers for putting up a great show. And my deep gratitude to Kamal sir for being the part of this organizing team and constantly guiding me through the thick and thins of the today's event and to make the event successful. Last but not the least, my acknowledgements to all the faculty members, students of different departments for gracing the presence and for their keen interest into the lecture. With your due permission, esteemed sir, and faculty members and students of Deshbandhu College, I would like to officially conclude the event, sir. With your permission, due permission, sir.
Thank you, Dr. Gauri. Thank you. Thank you, Kamlesh sir, and that's all the people who are involved in organizing this webinar. Thank you all.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you so
everyone.
Thank you
much.
so
Have
much,
a
sir.
nice day.
Okay, I will mail that newsletter to you.
I'm ending the.
And I will certainly visit Geology Department once the conditions are normal.
Yes,
to
definitely.
see.
You are always welcome. Okay,
you.
bye.
Bye.
Okay, sir.
Bye,
Take care.
Dr. Manisha. Yes, bye.
Thank
Bye.
you, doctor. Thank
Okay,
you so
bye.
much. Thank you. Thank you.